Let's do some questions based upon the effective stress analysis. So this is the first question. In this, the strata consists of sand, clay and gravel, and these are their respective depths. And on the top of this strata, some loading is applied. So because of that, a stress of 58.86 kilonewton per meter square is there. And the water table is below 3.5 meter from the ground surface. So we have to plot the total stress, neutral stress and the effective stress diagrams. So let's find out these stresses on each of the sections, each of the four sections. So on section 1 total stress is just because of this overburden pressure. So it is 58.86 kilonewton per meter square. If no overburden pressure is there, then total stress at the top of this strata will be 0, and pore water pressure is 0 because water table is at section 2 and there is no capillary rise or anything, so just the water level is at section 2 and there will not be any further increase in the water content above this section. So at section 2 similarly here at section 1 effective stress will be equal to the total stress because it is the difference of the total stress and the neutral stress. So at section 2 total stress is equal to total stress at section 1 plus unit weight times depth. So unit weight is 16.17 and depth is 3.5 meter. So from here it comes out to be 115.45 kilonewton per meter square. And pore water pressure is again 0 at this level, and effective stress will be equal to the total stress. Similarly at section 3 total stress is equal to total stress up to 2 that is 115.45 plus unit weight of clay times the depth of clay, so that is 19.13 into 3. So from here it comes out to be 172.84 kilonewton per meter square. And pore water pressure will be there because water table is above 3 meter from this point at section 3. So pore water pressure will be there for a depth of 3 meter. So it is equal to 29.43 kilonewton per meter square. And effective stress is 772.84 minus 29.43. So from here it is 143.47 kilonewton per meter square. 143.41. And similarly for section 4 total stress is 172.84 plus 3.5 into 18.88. It is equal to 238.92 kilonewton per meter square, and U is equal to, that is 3.5. The depth of water at this point will be 3.5 plus 3, that is 6.5. 6.5 into 9.81, so it is equal to 63.765 kilonewton per meter square. From here effective stress is equal to 175.155 kilonewton per meter square. Now we have all the stresses and at all the sections, so we can plot it here. So first the total stress diagram. So at 1 it is because of the surcharge, it is a constant value, and after that it increases with the slope of this unit weight of sand, with a slope equal to the unit weight of the sand. So from there this line will be like this, and after that its slope will be equal to the unit weight of clay. So this slope is more. and similarly for this part. This is the diagram for total stress, and we know the value here, it is 58.86, and section 2 it is 115.45, section 3 it is 172.84, and here it is 230 38.92. And for pore water pressure, similarly you can plot. So in this region there is no pore water, it will start from the section 2 and its slope will be equal to the unit weight of water. This is the line. And similarly the effective stress. So up to the zone where there is no pore water, it will be equal to the total stress, and after that it will be less than the total stress. So this way we can plot these diagrams. And similarly, let's see the next question. In this question, this clay is there for 4 meter, and above that sand is there for 5 meter, but in this sand the water level rises up to 3 meter below the surface. So this depth is up to here, it is 3 meter, and in that 3 meter 1 more meter is saturated with capillary water. So this part, this 1 meter is saturated with capillary water, so this 2 meter is also saturated, and this 1 meter also saturated, which is this 2 meter is saturated with the groundwater table, or I should say gravitational water, and this 1 meter is saturated with the capillary water, and above that this partially saturated or dry sand is there, and for that unit weight is given. Similarly, unit weight for clay and all is also given. So in this case also we have to plot these diagrams. So let's mark these sections. At section 1 total stress will be 0 because there is no surcharge or anything. Pore water pressure and effective stress, everything is 0. At 2 total stress is equal to 17 into what is this depth? This remaining depth will be, this is 2 meter, this is 1 meter, so it is 2 meter. This is 2. This is 34 kilonewton per meter square. And pore water pressure, now this section 2 to up to here the capillary rise is taking place, so we know that in the capillary zone the water is in tension. So from water table this 2 is at 1 meter, so at this point the pore water pressure will be minus 1 into 9.81. This is minus 9.81, or let's take the unit weight as 10 for the simplification of numbers. So this is minus 10 kilonewton per meter square. So effective stress will rise in this zone because effective stress is the difference of total stress and neutral stress. This is 34 minus 10, so it is 44 kilonewton per meter square. Similarly at section 3 total stress is equal to 17 into 2, it is there for this part 17 into 2, and in this zone soil is saturated, so we are trying to find out at this point. So the depth of this part is 1 meter, and 2 meter above this. So it is equal to 17 into 2 plus unit weight of saturated sand is 20, 20 into 1. So 34 plus 20, it is equal to 54 kilonewton per meter square. And from here U is equal to, so at this level we are at the water table. So at water table the pressure is atmospheric, and when pressure is atmospheric then pore water pressure is equal to 0. Effective stress here is equal to total stress, that is 54 kilonewton per meter square. Now at section 4.4. So total stress up to section 3.3 plus in this zone also the soil is saturated, that is saturated sand. So it is 2 into 20. So this is equal to 94 kilonewton per meter square. And U is equal to, so now we are talking about the hydrostatic pressure. So section 4.4 is at 2 meter below this water table. So it is equal to 10 into 2, that is 20. So effective stress is equal to 94 minus 20, that is 74 kilonewton per meter square. Now similarly at section 5.5, total stress is equal to, total stress up to this point, that is 94 plus 19 into 4 is 19 into 4. So here it comes out to be 170 kilonewton per meter square. And pore water pressure, so pore water is there 4 plus 2 meter, that is 6 into 10, it is 6 into 10, 60 kilonewton per meter square. And so effective stress is 170 minus 60, that is 110 kilonewton per meter square. So now we know all the values of stresses, so we can plot it here. So total stress can be plotted as we plotted it earlier. So here it is 0. Next section 2 it is 34, and after that it increases with the unit weight of sand. So it is here, after that with unit weight of clay. If we want to write the values, so it is 0, then it is 34 here. At section 3.3 it is 54, then after that at 4.4 it is 94, and at last it is 170. Now the pore water pressure diagram. So pore water pressure in this zone it is 0. Then at section 2 pore water pressure is there due to the capillary suction. So at section 2 we found out that pore water pressure is minus 10. So it will start from this side. At section 2 minus 10, let's say it is here. So it is minus 10 like this. And after that at section 3.3 it is 0. And so it will come like this, and then it will keep on increasing up to section 5.5 with a slope of unit weight of water. So it will be like this. So if you want to write out the values, this is minus 10, here it is 0, and after that below 2 meter it is 20, and here it is 60. Similarly, we can make the effective stress diagram also. So up to here it comes like this. Then there is a increase in effective stress at section 2-2. That is, it was 34, it comes at to 34, then increases to 44. So at this section it will suddenly increase like this, because effective stress is the difference of total stress and pore water pressure, but pore water pressure is negative, so this value and this value will add up. So here it is like this much. So first at this point 34, and it is here it is 44, and after that it is just similar. So from here it will go with the unit weight of sand, and below that unit weight of water. So this is the diagram for all the stresses. You can write the values also. After 44 at 33 it is 54, because pore water pressure is 0, and at section 4 it is 74, and here it is the difference of these two, which is 110. Now we can do some variation of this question. Let's say if the water table rises up to the ground surface, and by not capillary area, not capillary zone, but it just the water table rises up to this level. So what will be the total stress and all the stresses at this point? So let's find out. So the total stress will be, now water table is at the ground surface, so total stress will be equal to, this depth was 5 into, so now for this depth saturated unit weight of sand will be there, so 5 into 20 plus saturated unit weight of clay is 19, so this is 176 kilonewton per meter square, and U will be equal to 10 into 9, because 5 plus 4 9, and water table is at the ground surface, it is 90 kilonewton per meter square. So here effective stress is equal to 176 minus 90, so 76 plus 10, it is 86 kilonewton per meter square. Now let's say this is for the condition when the water table is at the ground surface. Now let's say the this water table rises further above the ground surface, and let's say it rises to 2 meter above ground surface. Now what will be the changes in stresses? So in that case total stress will be equal to this, in this area only pressure of water will be there, so total stress will increase by the this due to water, so pore water pressure times the depth, that is 10 into 2 plus whatever this stress was there, so 5 into 20 plus 4 into 19. And similarly pore water pressure, before it was how much, this 10 into 9 plus now 2 meter is has increased, so 2 into 20, 2 into 10. So the effective stress in this case will be the difference of these two, so this increase in pore water pressure will cancel out, and the effective stress will come out to be equal to what it was before. So it is just 86 kilonewton per meter square, and here also it is 86 kilonewton per meter square. So here we can conclude that if the water table rises above the ground surface, so it does not change the effective stress, it will change the total stress and it will change the neutral stress, but the increase in total stress and increase in neutral stress will be equal, so those increase will cancel out that increase, so the effective stress will be same, it will not change. So I hope it was helpful. If there is any doubt, please tell me.